define some important functions on our random variable. So let's start with, we're going to let x be a discrete random variable. So discrete, not continuous, a discrete random variable. Defined on a sample space S from a given experiment. So we're going to define a function, p, from the values of my discrete random variable to the interval 0, 1, such that 1, p of x is greater than or equal to 0 for all x in my random variable. 2, if I sum up all of those probabilities, p of x's, I get 1. These things together tell us that p of x is between 1 and 0 for all x. And the third one is that p of x is going to be the number we assign to the probability x takes on that value x. All right, this function, p of x, is called the probability mass function. The probability mass function, or PMF. All right, we also want to define another function. Okay, let's get a new definition here. So the cumulative distribution function or the CDF, put that in parentheses here, the CDF for a discrete random variable, so discrete random variable x, is a function from the reals to 0, 1. So and how we're going to define it is that f of a, so for any real number, is going to be 0. So remember, this is a discrete random variable, so your x is equal to x1, x2, and so forth. It could be finite, but it is discrete. So 0 if your a is less than or equal to the smallest value, and the probability x is less than or equal to a. I'm sorry, it's equal to the probability x is less than or equal to a, or the sum x less than or equal to a of p of x. In other words, you're summing up the probabilities up to the probability of a. And that is if a is an element of x. And it's going to be 1 if a is greater than x sub n in the finite case. So if x sub n is my highest value, then any more than that, we don't add up any more probabilities. So it's like you're just summing up probabilities. The graph of a CDF in the discrete case is a step function. A step function. That's it.